Welcome to Study Time, a televised home learning program produced by Rwanda Basic Education Board.
Hello, Senior 6 chemistry students. How are you? Welcome back. Alan is my name, still with you in chemistry lessons. So we are still on our topic of chemical kinetics, looking at unit 14, which is about rate laws and their measurements. So today we are heading in for lesson 4, basically about calculations. So without taking much of our time, let's really look at what we shall look at in today's lesson. So in the previous lessons, we were looking at measuring rates of reaction and the day-to-day applications of rates of reaction, whereby we looked at the rates of reaction. The knowledge is applicable in a medical world and the synthesis of fertilizers and their application, and even in the drugs that we take, knowing the drug will take about 4 to 8 hours. That maybe during that time, there is a need for another portion or another dose to ensure that the reaction or the drug is working effectively. That is what we looked at in the other lessons. Then we concluded up in lesson 3 by looking at determining the order of a reaction. And the method we looked at was the initial concentration, initial rate. We looked in details about it, so now it's time to apply the knowledge we looked at. So today's lesson will be mainly about applying the initial concentration, initial rate, experimental results in determining the order of a reaction. And that will involve, of course, calculations. That's why I will tell you, be ready with your scientific calculator. We shall need it. Actually, we shall be using it throughout the whole of this lesson. Please get it with you. If it is not with you, get a friend who can be having it. Then we get started. So our objectives today are basically to perform correctly calculations involving order of a reaction and the overall order of a reaction. Then, basing on the values we shall get, we deduce how the rate changes when the concentrations of the reactants are simultaneously changed. In other words, suppose we change all the components of a reactant. So what will happen? And that is what we shall be looking at in today's lesson. So this data is going to be helpful unto us as we calculate. It's again a reminder of what we had looked at. To the students who are maybe joining us and they did not attend the previous lessons, for you not to miss up today's content, this information is crucial for you to catch up. So for any reaction, if you consider A plus B as reactant, giving products, the aspect of products isn't essential at the moment. All we need is to see how the changes in the concentration of reactants. That's why the products are not focused onto much of this topic. So if you have reactants A and B forming the product, in that case, the rate law or the rate equation is the coefficient or the rate constant, K, concentration of A raised to a certain power. Call it A, call it B, it depends on to what you want to select. And this is what we consider as the order of a reaction. That power A, concentration of B raised to a power B, that is the order of a reaction. So as we looked at, if we keep the concentration of one of the reactant and vary the concentration of the other, then rate is likely to change. So that change is what we normally look at. For instance, considering B constant and you alter A, when you double the concentration of A and there is no effect on the rate of reaction, that becomes zero order. In other words, that letter, that O, which is the power, that's zero. Any letter or any number, power 0 is always 1, and so you end up having that. If you double the concentration of reactant A in this case, and the reaction also, the rate of reaction also doubles, then that becomes a first order. And if you double the concentration and the rate increases by a factor of 4, that becomes a second order. So with this information is what we shall mainly be applying in terms of our calculations. At the end, I left you with that exercise. I'm pretty sure most of you tried. So let's go through all the 2 methods in which we can answer part A. And that would be calculation method and the inspection method. If you tried, that's so fantastic of you. So the point here would be us seeing how your answers and our responses can converge, can connect up. If they are not correct, then you correct them. If they are correct, a thumbs up. Then to the students who are joining for the first time, still it will be an opportunity for you to see how you can quickly go through such calculations. So the question, you have it, it's even clearly indicated on the slide, but I extracted the crucial information which you see here on the board. I extracted the crucial information as you see on the board. Now, let's quickly go to part A without taking much of the time. It says determine the order of a reaction with respect to reactant A and reactant B. For this case, we had an equation which is A plus B going to product. So we are to use these experimental values, initial concentration, initial rate, to get the order of reaction with respect to A and B, then we determine the overall. Of course, the first part is to take an assumption. So we're going to say, let order of reaction with respect to, you can use it, it is allowed, with respect to A, B, let me call it X. Again, this is up to you. Call it S, call it M, call it A, call it whichever. I know some of you are having friends with specific names attached to you. You can use that name, like maybe Saison or M, Margaret, whichever. This is the first assumption we're taking. Then, again, we also take the assumption and say, let the order of reaction with respect to B, now call it Y. Again, it is up to you. Whichever letter you use, it is not of a big importance in there. But you need to actually identify what they imply. So, and in this case, what would be the overall? Then we shall find that the overall order of reaction will be X plus Y. When we get these values, we shall simply add. Now, can we go and see how we can get these orders? The first thing we need is to get the rate, which we call the rate law or the rate equation. And the rate in this case will be a constant, the rate coefficient, concentration of our reactant, which is A, raised to its order. Remember, we said it is X, then concentration of our reactant B raised to its power or raised to its order Y. I call this equation 1. We're going to be using it now and again. So, how do we get X and Y? We are to look into our table. Take a close look. Take a close look into our table. We are to select at least two experiments whereby the concentration of one reactant is maintained constant. Then we see how the rate changes when we double the concentration of another reactant. In this case, let's start with A. So, which experiment can we use whereby the concentration of B is remaining constant? If you look closely, if we take experiment 1, they are all the same. Experiment 2, concentration of A is remaining constant, indicating these two won't work. So, if you take 3 and 4, it is constant, so these two won't work. Remember, we are still looking at reactant A. So what do? We need to find where the concentration has doubled or has changed. You see it is experiment 2 and 4, or experiment 1 and 3. In 2 and 4, B is remaining constant. Do we see that? Excellent. In 1 and 3, also B is remaining constant. So, choice is yours. Let's start with for A. So in this case, you can either use experimental values for 2 and 4, alternatively 1 and 3. Choice again is yours. So, okay, then if you have a friend and you're doing this part or you're attending this lesson together, let one use this and another use this. If you're 2 people or 3, you pair up and one uses this and another uses this. So me, I'm going to use 2 and 4. Let's substitute these values in our rate. So we shall get 2 and 4, which is experiment 2. Rate is 5 exponent negative 5 is equal to a constant which we're having in here, concentration of A, which we're having as 3 exponent negative 2, power X, and concentration of B, which is 6 exponent negative 2, power Y. Okay, experiment 4. What's experiment 4? 21.6. This value here, K, concentration of A, which is 6.0 exponent negative 2, power X, then concentration of B, which has remained constant, power Y. So this is equation 2, equation 1. To get X, or to cancel the K's and Y's, we need to get equation, this I called it 1, let me call this 2 and 3, to distinguish 1 here. So we need to get equations 3, divide it by equation 2. When we do that, quickly, you'd end up having this divided by that. Okay, for the case of correction, let me do it. 21.6 over 5.4 equaling to K constant. Then the amount here, which is 60 exponent negative 2 times This is power y. Do not forget our powers. 6, 0, exponent negative 2, power y. We do here, this is 3.0 exponent negative 2 power x times 6.0 exponent negative 2 power y. So what do you notice? This will cancel with this. This, the whole of it cancels with the whole of this. So we remain with this and this value. I told you, calculators, can we substitute in? Get this divided by that value. Exponent negative 5, 5.4, exponent negative 5. This directly gives me a 4. And this, by quick math, this is a 2. The values are the same. This is 2 power x. And applying your math, this directly means 2 power 2, which is 2x, indicating our x is now 2. You see, we've gotten that value so far. Now, this is our x. Let's try for b, for y instead. This is 4x. Let's do for y. For y, the same application. What do we have? Let's see, we can use 1 and 2. After all, concentration of A is remaining constant. Okay, let's use 1 and 2. So I will use experiment 1 and 2. In this way, using experiment 1, what do we get directly? Let's substitute very fast. It is 2.7 negative 5 is equal to k, the value for A, which is 3, times 10 power negative 2. Our x, we can leave it there, times 3 times 10 power negative 2, value of y. We do the same thing for experiment 2, which is 5.4 times 10 power negative 5 is equal to k. 3 times 10 power negative 2x times, this is 6 times 10 power negative 2y. Again, get this, divide it by here. You would end up having 2 to 1. You would end up having, quick math, this is a 2. Quick math, this is a 2. The k will go like how we've done it, just right here. Transfer this knowledge to here. This will go, we shall only remain with 2 powered y. From your math, again, you remember PCB students, you take some math, so you can't lie to me. So 2, any number power 1 will always be that number. So indicating 2 has a power of 1 on top of it. So what will be y? Will be 1. That is equating the powers. So do you notice so far? We've gotten x and y directly. So the question is determine, so this is our order with respect to A. This is our order with respect to B. The overall. How do we get the overall? Remember, we've already stated it here. It will be x plus y. So it will be 2 plus 1. And you get your overall order as a 3. So that is the first method, the method of calculation. Let's try an easy but somehow complicated method 2. Let me call it method 2. That is by inspection. We are going to inspect. Let's inspect together. So if you look at our table. For the inspection, you want to find out if I maintain, we are going to still use experiment 2 and 4. What do we see? If I use 2 and 4, concentration of A was doubled. When it was doubled, get this value and divide it here. You will see the rate also increased by a factor of 4. Now this is where the inspection comes in. Using this and 4, concentration of A, which I call A bracket, is doubled. Then the rate increased by a factor of 4. Question, where do I get this 4? Simple. Get this value, divide it by this value. You will directly get our 4. It is just right here. So since it increased by a factor of 4, what does that imply? The order of reaction with respect to A will be a 2. Remember what we started on with? You remember that? What we started on with. This is by inspection. So the crucial part is stating the rate increased by this factor. If you don't state it, then your inspection approach will not be applying. The same thing, if you use inspection on this part, you will notice that when you get this divided by this, you'll get a 2. So that indicates when the concentration of B was doubled, the rate increased by simply a factor of 2. In other words, it also doubled. And that gives you the order 1. That is by inspection. Let's not take much more time over here, but by inspection, that's how you quickly do it. You see how I've come to it. You can still use the same approach to get the order with respect to B. So that is how you quickly come up with some calculations. Now let's go to part B. Part B, part B, part B, part B. What does it say? Write the rate expression. Rate expression, directly, it is a matter of substituting our orders in this equation 1. Substitute the orders we've got in this equation 1. So the rate will be K, which we yet to get, concentration of A, the order with respect to A is 2 squared, and concentration of B. So this is our rate expression, since the order with respect to B is 1, and that becomes the end. Next, C, the rate constant, and reduce its units. So we get the rate constant directly from the rate expression. In this category, find any experimental value of your choice. You see, in these calculations, you choose. It is up to you to choose. So you find any experiment of your choice and substitute the values. For instance, take 4. Let's take 3. It's the one which we haven't used much. Let's take experiment 3 and substitute it in here. So this is for the rate constant. How do we get it? Rate constant K. Let's use experiment 3. So that will be 10.8 exponent negative 5 is equal to K, which we want. The value of B, A, it is 6 times 10 power negative 2 squared times 3 times 10 power negative 2 power 1. So in this case, can we quickly get K? We shall substitute the units later on. So K will be, get this, divide it there. 10.8 times 10 power negative 5 units here, it is mole per decimeter cubed per second, divided by this value, 6 times 10 power negative 2 squared times 3 times 10 power negative 2. Here the units, they will be, when we join up these units, mole cubed, then decimeter power 9. Because we are having a 2 and this is a 1, then we shall simply add them because the units are the same. So in this case, you calculate. Please use your calculator to find up that value. And if you are following it up, depending on your calculation, it should get you 1. And the units in this case will be, this unit will cancel, part of this will cancel with part of here. So it will be decimeter negative 6 per mole squared, then per second. That should be, then this will go. This will be a positive value there. Then you get your final answer like that. So that is what was expected of your calculation, both by inspection method and by calculation. In that way, all these calculations we've gone through should equip you with enough knowledge and experience to do all your numbers. That is it. I will leave you with the practice question. I call it practice question 3. If you look at our previous lessons, each practice question for the class, I've given it a number. So I will leave you with that for you to calculate, and that is the end with the calculations. In the next lesson, I hope we shall do something else. Thank you for being part of the lesson. And stay safe. I want to see you in the next lesson. Bye.